No, it's okay. This is
Okay.
Okay, I've got it.
on the same thing.
On the same thing. No, I went off. I quit.
But you refreshed.
No, not just refreshed. I closed and opened the new window.
But with the same link.
Yeah, with that link.
Oh, that's weird.
Yeah, with this link.
That's good.
But I'm getting all the YouTube.
No. This is the old stuff.
Oh.
This is the recorded version of the old stream.
Oh.
Okay.
Three people watching now.
Where?
It says, oh, that should be the two of you plus either Aarti or Vignesh.
Okay.
So you tell
I sent a
Aarti.
new link.
Right? In response, on the
Yeah.
same message?
You have to tell Aarti to send
I
a
haven't
reminder
got
thing on WhatsApp because people will be watching on telephone rather than email. Do you tell Aarti?
Oh, no. I don't have one.
Can you get actually? Can you just give me the other
Okay.
phone notebook?
Where is it?
Okay. If anybody... Oh, there are 5 people now.
Okay. Is Vignesh there? No, this one. Yeah.
If anybody else apart from Vignesh and Aarti are there, please write something.
So the three of us are there.
6 one.
Oh, that's 6.
Yeah.
So-
Go ahead and send that WhatsApp
Okay.
if we are on. So yeah.
The new link.
Oh, all right. It's a new link. Tell them to do look at the new link, latest link. Oh, okay. All right. Okay.
Okay. So, hello everyone.
No.
Whoever's
That's not
there.
the one. That didn't work. You have
There's
to
a
change
new
it.
link here.
There's a new link that came. All right.
Okay. So what's the
But
plan?
that's a recorded old version.
Well,
It's not-
There are some
Watching us?
Yeah.
Yeah. All right.
So,
So
the
there are
plan
8
for
people
today is that
watching
if
now.
you guys
finish.
Yeah.
sorry, there's
Okay. All right. Okay. All right. Yeah, I know. Oh, okay. Yeah. All right.
there are 10.
Yes. Which
We should.
no. This is only for the current. Yeah. Okay. All right.
Okay. Hello, the 8, 9, 10,
10,
people
11.
Yeah.
over there. Okay. So I guess the plan for this 1 hour is that you guys ask us questions about stuff you've read in meetings, and you have stuff questions about other things. It's on you. Ask
So-
us questions.
Go ahead and start.
And sorry for the little delay and the new link for the stream. There was a problem with the internet connection, so things got a little messed up. Okay. So I guess we wait for
Yeah.
you to, or we have a new person, so we wait for you to ask questions.
You have to type the questions. You can't.
Yeah, so there's a
That's
chat feature on
Yeah.
the side. You should be able to ask us questions through that. Okay.
It would be nice if asking, introducing themselves.
So I should type that. So ask. Okay. Okay. So
We can, I guess, begin by asking if they found the second LT.
asking them questions would be a little hard.
Yeah, because they won't be have to type and it's
Okay. So. Okay.
Okay.
Curious.
Oh yes, yeah.
This is This
Hi
is part-
Sumitra. Yes, this is part of the our summer course, which started, I guess, a few weeks ago, end of May, and
this is for
this is for people who've already gone through the first few learning
Learning.
triggers for the course. So it may you're welcome to hang
Welcome
hang
to watch,
around,
but yeah.
there may be things we assume which people say which which are based on what they've read already and seen already.
Yeah, we've actually finished 20% of the course.
Yeah,
20%. Oh yeah.
Yeah.
That's
oh,
right.
that's the voice you hear is Tara. She's doesn't want to be on camera.
Well, there isn't enough room there for three
We can always find you.
But we'll get space.
That's not the reason.
Yeah. Okay. So it might be useful if we get started. What do you? So was there anything in the Pune monthly meet or the Chennai monthly meet which people want to talk about, which we can talk to a broader audience?
I think one thing that some people found difficult was the geometry question about straight angles.
yes.
Yeah.
The same.
Hmm.
Yeah. Oh, yes. Feel free to stick around.
Yeah, sure. Yeah.
Okay. So So let's just break.
So actually, one difficulty was how can a straight line be a triangle?
Yeah.
Right.
Because
Right.
I think that was one major difficulty, and I think that had to do with the visual image of triangle. Okay, so
And
we
not
have
showing
a whiteboard here, so we can briefly say what happened. The question was, if you have a line, can you see? Is that visible?
No, wait,
Not really.
not yet.
A, B.
There is a time lag between.
No, but it's not more than that. It's
It's
that's
not,
CU.
it's not CU.
Um,
No, I don't think the
okay,
board
then we
is
may
going to
need
work.
to
get a piece of paper.
get a piece of paper and not use the.
Yeah, I think
Whiteboard.
unfortunately the internet is a little slow, so the quality of the stream is not as good as we want it to be. Hope if this is worthwhile, next time we try and do it in another place with better internet. Yeah, so the basic idea of this is that, so say you have a straight line, can that be a triangle? And so Mo is going to draw.
Have some paper.
Are you going to draw this?
Yeah,
Okay.
this one is better. So this
Can
was
you
a
put more light on that?
no. If you have a straight line AB like that, and suppose you have another line, let's say CD, and yet another line E, F.
And you're saying D and E coincide?
No, you bring these things together. Bring this line here and bring this line here so that this will be C, D, E, and this will be F.
So D and E coincide at this point.
So there are
they're the same point.
3 lines there.
Yeah.
Even though it looks like a single line, there are 3 lines.
Right. So the 3 lines are A, B, C, D, and
DF.
E, F, D, F, whatever.
Yeah. So it's the 3 straight lines, and these are touching. So there are 3 angles also.
Yeah.
Then that you have a triangle. Even though it looks like a straight line, it's actually a triangle because there are 3 lines.
Yeah. Okay. Arpita has just said hello. Hi, Arpita.
Hi, Arpita.
It would be nice if others watching would also just say hello, so we know who is there, who is watching.
Yeah. So another way of thinking about it is to say there is this A, B, and C. That's a triangle, and you bring this C all the way down here.
You keep shortening.
Yeah, keep shortening, and here. Notice that the same case, exactly as in this case, there are 3 straight lines, and you have 3 angles, and 2 of the angles are 0, and 1 angle is 180 degrees.
Yeah. So this angle, the angle ADB, is 180 degrees. The angle DAE or DAD is 0 degrees, and the angle DF or DBE, or however you want to say it, is 0 degrees.
That's also 0. Yeah. So the sum of angles remains 180 degrees.
So it has that property of a triangle.
So the difficulty is to see that what looks like a straight line can actually be a triangle depending upon how many lines there are.
Yeah. So now it depends on your definition of triangle.
Yeah.
Right. So if given the regular definition of triangle, which is 3 straight lines, so a polygon with 3 straight lines.
Yeah. Right? This will work.
Yeah. So something, a closed shape. It's definitely closed. ADB is definitely closed.
Yeah.
And a closed shape with 3 straight line sides is a triangle.
Okay. This was one of the difficulties of the face-to-face meeting.
Okay.
Yeah. So Sumitra says the board and the line are visible, so all this must have been visible.
Okay.
Hi, everyone else who said hi. Yeah.
Arjun wants to see Tara.
That is Tara's hand.
Yeah. That's the most he cares. Yeah. Okay.
So any questions from your side?
Or any questions on what we just said, because that may not have been clear at all.
Closed polygon.
Whose definition is that? That's the usual definition, right? A polygon with three sides.
Yeah, three-sided
polygon is a triangle, right?
Yeah.
That's the usual textbook definition of a triangle.
And the definition of polygon involves straight lines.
Yeah.
And a definition of polygon involves 3 straight lines and closedness, right? Straight lines and closedness.
Yeah. So in this case, who is asking this question?
Sumitra is asking, what if we add the condition that a finite area be enclosed?
Right.
I mean, 0 is a finite area.
0 is finite, and so you have to, rather than say finite area, if they say the area cannot be 0.
If you don't want, if you want to remove that case, then
then this will not be a triangle.
Yeah,
but
area cannot, or if you state the condition that you want the sum of 2 sides to be larger than the third side, strictly larger.
Or you get an angle cannot be 0.
Yeah.
These are all possibilities.
Or an angle can't be 180.
But to do all that, you have to say something special to avoid this situation.
Yeah.
Otherwise,
so notice something. If we take an example which is similar.
Here's the pen.
Yeah. So
you want this paper or something else?
A new one. So if you look at this, A, B, C, D, right? That is a quadrilateral.
Provided that these are two lines,
Yeah. So
not
we
just one line.
No,
yeah,
maybe
so this is 180 degrees.
Yeah.
This angle. That is
and the other
something.
three together is
180,
180. So
we
you
know
get
that.
360.
Yeah.
So you got 360.
Yeah, but once again, it looks like a triangle if you think of this as a single straight line. But if it is a combination of two lines joined together like this, then it's a quadrilateral.
So you can think of this as a quadrilateral. So the basic idea is that you can think of this as a quadrilateral. You can think of it as a triangle. But it depends on how you are defining quadrilateral and triangle, and how you're defining the particular shape. So if you define this, as Mo said, as the lines A, B, B, D, and DA, then it's a triangle. But if you add in the line, if you make it A, B, B, C, C, D, and DA, then it's a quadrilateral, right? And you can add another point here.
It becomes a pentagon.
Pentagon.
A pentagon.
Not simply adding the point, you have to say
adding the line.
Yeah.
So you're adding, now this is, you're not adding the line, you're breaking up a line into two lines. And so now it's a pentagon. And it preserves the property of the sums of angles, which you would expect from polygons. What it does not preserve is the property of, say, the usual property, right? Because in this case, when you have a triangle like this, which is basically a line, which is a triangle or a pair of three lines, then the sum of the lengths is equal to the length of the entire thing.
But there's another way of stating that. You can, rather than saying that the sum of two sides should be greater than the third side, you can say the sum of two sides should not be less than.
Yeah. So if you state the triangle inequality in that way, then this works. But if you say the triangle inequality in the stronger form, then it doesn't work. Yeah. Right. Then this is not a triangle.
So the point here is really talking about the definitions and the consequences of the definitions.
Yeah, so it depends how you
And
define things. So in
judgments.
with some definitions, this will be a triangle, and some it won't. And with some definitions, it will be a quadrilateral, and others it won't. Okay. So Sumitra says, so a circle is a line. Every line a circle. So it depends.
There was two different questions. Every circle is a line, every line a circle. They're two very different questions, actually.
Right. So when you say a circle is a line, so now it depends what you mean by line. If by line you mean straight line, then on a flat plane, a circle isn't a straight line, right? Because what's a circle? It's that so we're just picking like regular textbook definitions. A circle is the set of points at a certain distance from a given point, right? At a distance, say R, from a given point. If all these points which are at a distance R from a given point, then this is a circle. But this is not a straight line if by line you mean the shortest from the circle, right? If you're on a flat plane and you can go through. So that's definitely not a circle. And then, which direction was that? So a circle is definitely not a straight line.
Mm-hmm.
And a line is definitely not a circle because there is no point,
Right.
which is, unless you're doing projective geometry. And then in that case, things get good.
So here's another question. Arpita says, even if we prove that a line is a triangle, how can we measure its three angles?
So now we're doing mathematics, right?
Yeah.
So so it's stipulated when you set up the shape, rather than measuring a given shape. That's not what because in mathematics you don't measure, right? You measure.
Is because a line is defined as an entity that has zero breadth.
Yeah, in Euclidean geometry,
Yeah.
a line doesn't have any magnitude.
So you cannot see it. You can, of course, see these things, but they don't have zero breadth. These are not lines, they are representations of lines. So measurement is impossible if you define things.
So this thing, when we created it, this is not actually a triangle, neither is this. These are representations of triangles. And if you want to actually define a particular triangle which fits this representation, you'll stipulate the angles when you define it, right? So you'll say that this angle is...
by definition is Two right angles.
two right angles, and these two
Yeah.
angles are 0. So you actually state that as the definition of this, not of this, but of what this represents. Okay. So, anything else?
The questions don't have to be only about geometry.
Yeah,
Can
yeah,
about
yeah.
other
Anything,
things.
yeah.
Other things in LT1 or LT2.
Yeah.
Yeah. Any questions you want to ask?
And we're not, to respond to Arpita, we're not actually Arpita says even if we prove that a line is a triangle, whatever, we're not proving that a line is a triangle. We are saying that if you have 3 lines which are arranged in this manner, then that's a triangle. A line itself is not a triangle.
By itself, it doesn't fit the definition.
Yeah.
So
it's just that these lines
looks like a straight line.
Yeah.
What looks like a straight line is not necessarily a straight line.
Yeah, it may look, but it has 3 parts of the line, or three
lines
points,
there.
which are on top of 3 lines which are on top of each other.
Which is what
At least 2
Yeah.
are on top of the third one.
What is
Okay, a little unrelated question. Is it?
Chirantan has a
Yeah. Well, Sarah, you
Can
can.
you read out the question? I
a
can't see.
little unrelated question. Is it possible that the definitions of all these figures, circle, triangle, etc., would have evolved over time? Wherein, as was our exercise in LT2, the definition would lead someone who doesn't know anything about the figure, arrives at only the figure on following the definition.
By figure, if you mean what you see on a piece of paper, then what you see on a piece of paper are not geometric objects. They're simply representations of geometric objects. This is like saying, this is important to understand, that if I do this,
Drawing a monkey.
well, this is not a person. This is simply a representation of a person.
Yeah, so punch their face.
Yeah, nothing happens.
It's
right?
okay. I won't go to jail.
Yeah. So the same way, the kinds of pictures that we draw, this is not a triangle. This is a representation of a triangle, and it is important to separate the two. An actual triangle in Euclidean geometry, if these things represent 3 straight lines, they are invisible because the lines have no breadth. This is important to understand. So we're talking about invisible entities. They cannot be seen, they cannot be measured, but we're simply drawing them.
So there's the other part of the question, which is it possible that the definitions of these figures, evolution is not the right metaphor, definitely, because evolution implies that there's like gradual changes which then manifest into a significant change. But there definitely has been huge changes in geometry, right? So before Euclid, geometry was measurement. Since Euclid, geometry is based on certain axioms, certain principles, which then you deduce the consequences of. But Euclid believed that there was only one type of geometry. It was only with people like Lobachevsky and so on, in much later on, that people realized that there wasn't just one type of geometry, and so there were many axiomatizations of geometry.
And there are different kinds of geometries.
Yeah.
And they have different theorems.
Yeah.
Can you read out that question?
Yeah, the next one? Yeah, it's in my school, children learn about shapes and their properties at grade 1 and onwards. How can I simplify this inquiry for them?
Grade 1, we would suggest don't try this.
You can't do mathematics as mathematics in grade 1.
Yeah.
They can look at shapes and identify shapes and play with them and whatever. Think about congruence and all of these sort of concepts, but definitely not think about
even congruence without using the word
congruence.
Yes.
Right. So you talking about do things fit on top of each other and so on. Yeah. But when you were but not Euclidean geometry, because Euclidean geometry is extremely abstract.
And that abstraction happens only later, say, for 5th grade, perhaps.
Even
that is
I think I would say teenage is when these abstractions can be understood. Until then, you should think of geometry as shapes that you can see.
And that you can play with.
Yeah. So you can think of shadows and you can think of folding paper and all that stuff, but not Euclidean geometry. That comes much later.
Okay. How can three angles falling as a part of a
Maybe it's useful to take Vedhi's follow-up before we move.
By properties, I mean 3 sides and 3 corners, etc. And then they use geoboards with rubber bands. Yeah, but
so that's all fine.
This is all playing with.
Yeah.
This is treating math as science, actually.
Yeah.
With real objects. It's not really thinking of mathematics as something abstract.
So when we talk about mathematics, we mean an axiomatized theory. So where there's a set of things which you assume to be true and you figure out the consequences.
See, this object that I'm showing you, it has the shape and all that stuff. This is not a rectangle. This is just a rectangular shape that you can see. A rectangular geometry is something that you cannot see. It has no weight. It has no size. It's just, imagine this edge taken by itself, just an edge, but that is 0 breadth. That you cannot see, you cannot touch, you cannot smell. It's just an abstraction. And it's
created via definitions.
Yeah.
So it's not created via drawing.
Children can see and touch these things, but not...
And identify that as rectangular. And
rectangular,
Rectangular, not rectangle.
That's right.
But it's okay if they call a shape a rectangle.
Yeah, sure, they can. But then at a later point, they need to make a distinction between rectangle and a rectangular object.
Yeah.
Especially once they start doing geometry.
Right. Yeah.
So, there's not a perfect straight edge. And a perfect straight edge doesn't exist in real life. This is an approximation of a straight edge, that's all. But in geometry, you need that just straight edge without any wiggles.
Should we go?
Yeah.
How can 3 angles falling as a part of a single line be called a triangle? Though as a mathematical definition, we know a shape having 3 angles and closed figure is known as a triangle. By 3 angles, I mean 3 points on a line.
Yeah, but it follows from the definition, even though it doesn't look like a triangle.
Yeah,
that is why you have to.
Meaning, it depends on your definition of polygon, if you allow for that. But with the usual in what's written in textbooks, it follows that thing is a triangle. The one we showed earlier. That's
points, and only those points that are equidistant from a center. And this is the radius of a circle. Now reduce the radius like this. That's a circle. That's a circle. And we keep reducing the radius until the radius of the circle is 0. If the radius of a circle is 0, you cannot see it. But if it's still a circle, it's also a point. Now that is the beauty of mathematics, that this is something that you cannot see, you can only imagine. And by definition,
and it's stipulated it's created by a definition.
Yeah.
It's not.
Yeah. What is the next question?
So does mathematics exist if sapiens become extinct? But I guess
outside.
Yeah.
That's a philosophical question.
Which the philosophy. So read philosophy of mathematics.
Yeah.
Yeah.
We won't go into that in an introductory course like that. It's a fascinating question, but we will not go into that one.
Yeah. You can just Wikipedia the page for philosophy of mathematics. You'll find enough links and so on to get into that.
Yeah. You'll also find lots of videos, YouTube videos that mathematicians disagree on. Yeah.
Okay.
So do you suggest that other than exploring geoboards, etc., we could do observations like reading?
The reading
one suggests only a simple
bed type.
I'm not sure.
Yeah, difference and distinguishing with value.
I should also say that at this point, you should not think about what you can in the classroom. Maybe you should start thinking about it only after IIE is completed.
Yeah.
At this point, try and figure out what the difference is between mathematics and science, and how you construct mathematics, how you come up with proofs, and similar things in science.
Yeah.
The teaching part is much later.
And also, the teaching part in very young classes shouldn't happen even at the end
Yeah.
of that. This comes in only at a much later stage.
Yeah.
So
And we definitely have thought very little about teaching for younger kids. We have some ideas.
but we do
Yeah.
know that it doesn't work. Abstraction
That's
doesn't work
Yeah.
before a certain age.
Yeah.
So
But specific questions like this I don't think we are the right people to respond
Yeah.
to. You probably are the right person to figure things out once maybe at the end of this.
But after doing it.
Yeah.
what is the role of abstract concepts in knowledge?
There's a question before. As our observation, even a dot can be called a circle, but the case for a triangle is different. We need to have an enclosed figure with three distinct points. So there are three distinct points on three distinct lines.
The lines are distinct, they just happen to coincide.
Yeah, right? Yeah. Here are the lines. One of the lines is AB. One of the lines is CD. Let's call it CD. And one of the lines is EF.
Yeah.
These are three lines.
Yeah. The difficulty is that you're assuming that a triangle and a circle have non-zero area,
which you can do. But then you've changed. You not necessarily change the definition, but that's the definition you're using, which is fine. That's you just have to figure out the consequences of that. But
okay, what's the
role of abstract concepts in knowledge?
Most of the concepts that we have, even like concepts that 2-year-olds have, even before they come to academic
school, before they come to school.
Yeah. So, for example, take the concept of mother's face, which a child can recognize fairly immediately. But that face is actually a fairly heavy abstraction, because my face, if you look at it like this, the stimulus that you're getting, if my face is like this or like that or like this, or the light is changed, very different. Likewise, look at my fingers or my hand. Regardless of the particular shape, every child recognizes this as hand. That's an extraordinary abstraction. Children can do that, but this is not an academic abstraction. This is a real life abstraction. Triangle and line and geometry is the next level of abstraction.
And there's things in between, right? There's like numbers and so on, which
so one of the next levels, not immediately
the
next level necessarily.
Abstraction based on experience versus abstraction based on definitions and axioms. That's what we are struggling with here.
Yeah. And when you say what is the role of abstract concepts in knowledge, that's all what knowledge is about.
Yeah. You can't have knowledge without abstraction of some kind.
Yeah.
Even when you say dogs have 4 legs, you're not referring to any particular dog.
Yeah.
It's incredible abstraction. Leg, what is leg?
When you talk about words and sentences in a language,
Yeah.
you're abstracting away.
Yeah.
So it might be useful to say what we mean by abstraction.
Yeah.
Because by that we mean keeping hold of certain properties of an object and forgetting the rest.
Yeah. That's an abstraction.
So like this is one finger, but let's forget the finger part, and this is just, and the abstraction for this is just one, right?
Yeah.
An abstraction.
Yeah.
And then this is one finger, this is one phone, but so one is the abstraction which covers both of these.
Which is the oneness of that concept.
Yeah.
The concept of oneness.
The same thing, when you say man, what you mean is that concept of manness. And you cannot touch that concept, you cannot see that concept. But if I point to this concrete entity sitting in front of me, that entity you can touch. This is concrete.
Yeah. So you can touch one phone, you can't touch one. Right?
Yeah.
What does that mean?
Yeah. Nor can you touch phoneness, which is
Your
what the word
phoneness,
phone means. Right.
And next question.
We probably got everybody confused. Abstraction, mathematics, and so on. Yeah. So, other questions that you have, not necessarily related to what we have been discussing, but in LT1, LT2.
Or anything else.
Yeah.
Consolidated feedback or
We have 19 people here. Oh, it's just become 20.
So otherwise, do we have some backup?
This is a space for them to ask questions. I mean, what we want to talk about, we'll send them LTs and other kinds of videos and various other kinds of things.
Yeah, we've been doing enough talking.
Yeah. Now you should be asking.
We'll talk.
Yeah. Yeah. That's the condition. Unless they ask questions, we don't talk.
Some of you have said hi, but not everyone.
Yeah.
So we don't know who else is there.
So my sense is that there are people do have questions, but they don't know what the questions are. That happens quite often. And there are things that people may not understand, but they don't know what it is.
In terms of abstraction.
Yeah.
A word and its meaning.
Is the abstraction is not necessarily the word meaning is not an abstraction of the word. A word word is something which represents the meaning.
Yeah. And
any meaning is an abstraction because you can't state every single thing about any entity.
A word represents something. You have to know the thing itself.
But it may not represent something as in an entity in the physical world.
Yeah. So if you say something
depends
like
what you mean
happiness,
by something.
Happiness is Can you touch happiness? Can you taste
Right.
happiness?
Yeah.
Measure happiness. These are all abstractions in this sense. But all concepts denoted by a word or words are abstractions. But those abstractions have to be connected to concrete entities that you can experience. Some of them, not all.
There was a question, you 5 years ago, and you 10,000 years ago.
This was the existence proof
in that.
Okay. So the question was, how do you know that you exist now? Yeah. How do you know that? Not how do you know? How do you convince me?
Yeah. For the people who didn't attend the one-day meet.
Oh, this was during that?
Okay. Yeah, it was during that. We raised this question. We didn't distribute it to everybody, did we? No.
No, we didn't.
Okay, yeah. So it was the idea is that we were interested in existence questions. So does air exist? Is there? Did you exist 5 years ago? Do you exist now? Did you exist 10,000 years ago? That was the.
That depends upon what you mean by you. Yeah. If the experience changes you, like after yesterday, I've had so many experiences. Am I exactly the same person that I was yesterday?
So it depends. Yeah. So now the notion depends what you mean by you. So if you're talking about the abstraction of you, which is common to what was there yesterday and today, where you've forgotten
or even 5 years ago.
Yeah. 5 years ago. Yeah. Then definitely.
Yeah. No, but then the question would be 5 years ago, 10 years ago, and at some point you're going to say, the person that I was inside my mother's womb, is that me? Or the unicellular organism
is that
I was conceived, is that me? Yeah. It's going to be very difficult.
And even when you're talking about yourself maybe 10, 15 years ago, like sometimes you look back and you say, was that really me? That people use the phrase, that wasn't me, right?
Yeah.
So there, the notion of you they use is a different notion of you to like the person with the particular with the particular driver's license or whatever that the same person can use the same identification card. Yeah.
Okay, going to the next. I've seen that there's a diversity among participants. There are people who are still in school, some in college, some working. What is the basic expectation you as a presenter have from participants at the end of the course? Just a general thing. Well, I don't think you can have, neither you nor we can have any specific rigid expectation from participants or you from yourselves.
In terms of age?
Yeah,
Yeah.
that it doesn't matter
Yeah.
how old or in what situation you are. The only expectation is both ways, inquirers and learners. And this is a lifelong process, so you cannot say, this is what I need to achieve by the end of the course. It's an ongoing learning process.
There is also another expectation would be that people can learn on their own from printed words or videos without having to sit in a classroom, because materials are reading materials. You should have enough English to read and understand, and you should have that habit of reading, habit of watching a video and learning. That is necessary, otherwise this course may not work.
Yeah, and also it's not expectations in terms of what you achieve at the end of the course, but during the course,
Yeah.
we do expect a commitment to learning and time and effort spent for that. And how much of that is entirely up to you, because each one's going to have, given their life situation, what's available to you is going to differ.
Yeah. There's no terminus, but the expectation is you should learn more than what you have now. That's all. There should be an increase in learning. There is another question now. What is that?
Sorry for asking late, but in the first example of the straight line, if we add infinite dots, can it be a circle? A circle is a set of points which is equidistant from a given point, right?
Given that.
Right. Yeah.
By the way, are you familiar with the materials? Have you done the course before? Because you're not a participant.
No. This
which Santosh.
Of course, some of these questions are not answerable.
No, but this is an interesting question.
Yeah. So this is a circle, right? A set of points at some distance from a given point. So if, say this we pick as a straight line, which is the point, which is the center point, which is from which each of these points is equidistant, right? If we pick this, say, this distance is not the same as this distance, right? Which is not the same as this distance, and so on. So this can't be a circle because there is no point such that that's the case.
Yeah.
So in other words, a straight line in Euclidean geometry cannot be a circle.
Especially just in Euclidean geometry.
Given this definition of circle.
That's right. Yeah. There can be other geometries in which it is possible.
Yes.
So it can be part of a circle.
So like look at art, like perspective stuff. There, in that case, a straight line is a circle, right? If the center is the point at the horizon.
Yeah, but we're talking about
Euclidean geometry.
Right?
This is not the case.
Thanks for asking that question anyway. Okay. Is evaporation just a change in state of matter, or is it a chemical change? What do you think?
For that you have to define chemical change, and as far as we know, most of the definitions that separate physical change and chemical change don't really work. So until we have the definition of chemical change, we can't say something is a chemical change or not.
Are they actual concepts which are used by academics?
Chemical change and physical change?
Like
they're in textbooks.
In textbook. I'm not about textbooks.
Yeah, in research it doesn't really matter.
In research, researchers don't.
Yeah. Okay. There are some concepts in textbooks that are not really needed for researchers.
Yeah. I'm just checking whether.
So if you actually ask people who are doing research in chemistry, and you ask them, the typical answer is, "Oh, I don't know what it means." It's just
it's something for
textbook
textbooks.
stuff. Yeah. It's needed only for passing exams.
More questions. It's not been bad. I think 10 minutes more.
Yeah.
If there are questions, we'll.
If there are
Yeah.
questions, otherwise, that's fine.
There are people still watching us who haven't.
Yeah, it must be really boring.
Yeah. Watching us but not asking questions. Maybe some of them fell asleep.
Yeah,
So
it's boring enough.
Do you want us to wake you up?
what's that question,
Oh.
Tara?
If you can help with the example where only physical change is there, where is it that
And again,
depends on what you mean
it
by
depends upon what the physical change.
you have to find
Yeah.
physical change
Yeah.
first, and then
So consider this. Sometimes people say physical changes are reversible chemical. That's
that's one of the.
Okay, try this. I changed this piece of paper just now.
You want
Throw
to
this.
hold it? No. Close. Oh yeah. Okay.
No,
Okay.
this is
Yeah.
don't. Yeah.
alright, Yeah.
By tearing this,
Uh-huh.
did that cause a physical change or a chemical change? Is it reversible? Like take a dry stick and break it. You can't put it back.
Or break an egg.
Yeah. Is that a physical change?
Yeah.
So there is no coherent definition of physical change versus chemical change.
At least nothing we've seen so far.
Yeah.
Especially when you talk about change in new substance and so on.
Yeah.
What is a
there
new
is no-
substance?
Yeah.
What is a new substance?
When you put two metals together, is that a new substance? Yes, it's a new substance. They have different properties. But textbooks will say it's a physical change. It is a mixture. It's not a compound. Again, it's the same. What's the distinction between? Nobody knows. It's just a textbook word.
The question's a bit different. Recently, the draft of the new national education policy has been put forth.
Okay,
Do you
that's
think-
not.
I think that's not-
Yeah.
That's
Yeah.
not something we're going to enter into.
Yeah.
Also, I at least I haven't read it. So
We've
Yeah.
looked at it, but
We
this
have
is not
looked at it,
yeah,
but
yeah.
we generally
No, we
steer
will
clear
not-
of.
yeah.
Governments
about-
will keep changing syllabuses and so on. What can we do?
Yeah.
Luckily, we are not teaching in a school, so
yeah, so we don't have to worry about it. So you guys have to.
Yeah.
Some of you who are either teaching in the school
Yeah.
or are.
But this
Learning.
course is not meant for teachers alone. It's
Yeah.
for anybody who wants to learn.
Yeah.
So we would say,
It's also there is a certain kind of learning.
And I was saying even students. There's a bunch of students here.
Yeah, that's
who
right.
Who will suffer,
yeah,
or it'll be good for them
Yeah.
depending on the policy. But we don't have to worry about it. So.
Okay. How to measure or decide area of inexactness when we are using manual counting or computer instead of instrument?
measure the inexactness. Okay, this is like saying, how do you measure some person's height? If you measure a person's height several times, the same person measuring the heights using the same instrument, and different people using the same instrument and measuring heights, you will see a range of some variability. And then looking at that variability, you can say, that is the degree of inexactness. So if you measure my height, if in terms of, let's say, millimeters, you will never get exactness. But if it is like, let's say, my height is between 5 feet and 6 feet, that is going to be okay. So you specify that degree of inexactness that you want on the basis of how much variability you get for a large number of measurements. That's how you specify the plus and minus range that you need for specifying measurements. Is that a new question?
Yeah, I think this is, I think, a philosophical question where we're not going to, let's go to the next one. I may not have figured out how to phrase this question correctly, but since our understanding of something depends crucially on the definition, and one can come up with alternative definitions, is the idea that there is general consensus on one definition over another, and we go with that in order to be able to communicate effectively. It's understanding of the different definitions and what the logical consequences of each of them is, the differences in the logical consequences, and then picking the one that
so you want to pick the one which makes the best predictions. You want the one which is the best definition, and we'll get to that eventually.
But I don't think that is we can explain that at this stage.
No, but
No,
you can. So you can give an example of, for instance, the word animal. If you look at like the regular English use of the word animal, it doesn't include humans, right? But if you take the biological definition, that includes humans as animals. So now we can argue for which one is the better definition out of those.
But that will depend also on the purpose of
On the purpose. So if
Yeah.
the purpose is for descriptive purposes, for day-to-day life, or if you run a zoo, then
It doesn't matter.
Then you need the other one. You need the one where humans are not animals, right?
That's right.
If you run a zoo,
that's true.
then you don't put humans in the zoo.
And we'll just put some of us in the zoo.
And you don't put worms in.
You don't put worms in the zoo.
What are the things in a zoo? Birds are okay.
Yeah.
Mosquitoes, no. Mosquitoes, cockroaches, none of these will be animals.
Yeah, so the definition, it's not a matter of consensus.
It's a matter of figuring out what's the best definition for the particular purpose.
Yeah.
And if you want to make predictions about biology, about living organisms, then having humans as apes, as whatever, as mammals, as so on, in the hierarchical structure, it gives us better predictions and it makes things easier.
The same thing applies to the word force. In English, there's a meaning of the word force. For example, I forced you to apply for this program. That's one. This is not the meaning of force for in physics, right? So you have to say what is the purpose of using that word, and you have to specify that.
And you have to argue for your definition over someone else's.
Yeah.
Sometimes there can be two definitions which are both useful.
Yeah.
That's fine.
Yeah.
Then you just state which one you're using.
Yeah. Actually, if this discussion is all too esoteric, then we're going to come to a discussion of defining and its relation to other tools of inquiry in a few weeks.
This is an LT4?
LT5.
LT5, okay. It's only then that many of the things that we've been talking about will become clear.
The pieces will start fitting together.
Yeah.
Okay. So if I'm counting the number of words given, or I guess written by
10 people in 2 minutes. Here I'm not using any instrument. Does this measurement have an area of inexactness? Yes. Depends on depends on purpose.
Yeah.
Why are you doing this? If you want to figure out how many words a person speaks when speaking continuously in a certain amount of time, then you do it for a number of people and see how much variation there is. The question is,
so I think,
what is it for?
I think even before that, so say I want to count the number of words in this particular statement which you've written, Priyanka. And so I may not get it exactly right? I make mistakes. Everyone makes mistakes, especially counting is hard.
Yeah.
So I would count it 4 or 5 times, and then there would be some inexactness. Maybe I'll get it. Sometimes I'll say it's 45 words. Sometimes it'll be 47 words. Sometimes it'll be 43 words. But there's some inexactness in my counting. So that would be. But assuming there is some inexactness.
So now this is the inexactness in the range of a person's counting.
Yeah.
Now,
but there is some difficulty in what's the word.
Right. No, also, I think what she's asking about is the range of inexactness in saying that people speak so many words in so many minutes.
Mm-hmm.
Now, in that, there is going to be a huge range of it, because people speak some people speak very slowly, some people speak very fast, and so depends on what you're looking at this counting for and what the purpose of that range of inexactness is.
Yeah. So there'll be some inexactness in each of the people you're counting, the words which they're saying, and then there'll be what you get, the variability across people. Which I'm not sure whether I would call that inexactness, but that's just variability across people. Yeah.
If you're doing this, obviously, it's because you have a question in mind of, about the pace of speech or whatever, and that how does this tie up with your question? All of those things are related. So,
and there are also cases where, in simple cases, if I count how many fingers do I have? You can say 1, 2, 3, 4, 5. But how many people were there in yesterday's rally? You are not going to count each individual.
It's an estimate.
It's an estimate that is going to be inexact. So in some trivial cases, the assigning of integers to a set of entities could be fairly straightforward. But anything beyond that is going to be extremely difficult.
I'm not sure if I would get that right every time.
Which one? Yeah, you can't even.
Mathematicians can't count, so
Yeah.
that's okay.
Forget about mathematicians.
Okay, here is a question. This is related to LT1 video, where you talked about killing a mosquito as morally wrong or not. Everyone almost daily kills mosquitoes because they bother us. But in case of other human beings, if we consider we cannot, for obvious reasons, kill because it is wrong. Do you kill mosquitoes, Simran? I don't.
Oh, you don't kill human beings when they bother you?
No, okay, seriously,
Yeah.
there are two notions of wrong. One is an emotional reaction. So there is something that our instinct tells us something is wrong, something is not wrong. So when you kill a mosquito, you don't have that emotional reaction that what I'm doing is wrong. But then that varies from person to person, right?
Yes.
When you kill a mosquito, you don't think it is wrong. What if you are killing a frog? What if you are killing a cockroach? What if you are killing a chicken? Different people have different levels of tolerance for that emotion.
And then you
About wrong, we don't mean that notion of wrong mostly.
We have to you have to begin with the definition. If you say something like, it is wrong to destroy the life of any living organism.
That's your axiom of your moral theory.
Yeah. Then killing bacteria is wrong.
Yeah.
Right?
Which is
Which
crazy
means-
because
which means that taking antibiotics is wrong.
Yeah.
no, even moving around is wrong.
That's right. You'll be
Breathing is wrong
right.
by that.
Yeah.
So clearly we don't want that.
But it comes
It comes from this principle.
definition.
Yeah. It
Yeah.
comes from the principle.
So
That,
it depends on what your axioms are.
yeah.
Ethical
So
axioms.
if your principles, you can't cause harm or kill any living creature, then you can't breathe.
Yeah.
If your principle is something like you can't kill or cause harm to any animal or something, then
Creature with a central nervous
Creature
system.
with-
That's
yeah.
one
that's
thing
one.
that people use.
Yeah.
Or it could be maybe it's all non-humans is fine, but
Yeah.
just humans is bad, and so on.
But even then,
You know,
the question is, what is the definition that you want to have?
Yeah.
right.
And sticking to that definition.
Then you mean your action. It's
Yeah.
not really a definition.
What
You're not
definition
defining.
of what is immoral or immoral?
Saying a definition of what is immoral,
Okay.
that's too
That's
many
The
stipulations.
axiom. That's
Your axiom.
Yeah,
It
the
also-
principle.
Of your theory.
In this, it also depends on where you draw the circle of us and them.
Yeah.
So the more that you think of as part of us, as like us, the less you.
If that's what your morality is based on, whether it's
Yeah.
how close they are or not, it may not be, right?
But even if you say killing a human being is wrong,
Mm.
the same people have no objection to killing an enemy soldier, right? Or death penalty.
Well, that's the questions are coming up.
Oh, I see.
So if my immune system kills something that's causing me a fever, is that wrong? Am I doing it or is it happening?
If your moral principle is that you aren't allowed to kill any living creature, if that's your moral principle, then you should kill yourself right now.
Yeah.
But then you'll be killing
Oh, you
living
can't do
creatures.
that.
Can't do that either.
Can't kill yourself.
There's a contradiction.
Either
there.
way, you'll be doing something wrong.
Okay, so there's a comment here. Maybe our morality is a function of habit and convenience.
Not necessarily, right? You can have a rational morality, and then you can say, okay, so there'll be some gray areas, but at
Yeah,
least
so you people definitely change their mind on morality through argument.
Yeah.
At least some people.
Yeah.
And
most people, in fact.
it's okay. The next question is an interesting one. What about euthanasia?
Yes.
So say your principle doesn't affect other humans, but you may also have another moral principle which says that
you have someone.
you need to help someone who's in pain, right?
Yeah.
And these moral principles will collide with each other when someone's in huge amounts of pain, and the seemingly the best way to get them out of it is to kill them,
and they want to be
and
killed.
they want to be killed.
Yeah.
So now there's a clash of moral principles, And now you have to. Now this is where moral reasoning is different from most other types of reasoning, and you have to choose between these two. Now you are in the particular context.
There's also something else that comes into this. If you want your moral system to be consistent, what if somebody disallows euthanasia, but is a supporter of capital punishment
And war.
and of war?
Right. You have no objection to sending jet fighter planes to another country to kill lots and lots of people.
Or capital punishment, right? But so it depends on what an individual's or community's moral system is, and what we're looking for is consistency within that. So these are that's the kind of questions you need to ask about this.
Yeah. So basically it's you're choosing, because you'll always be in situations where you choose between moral principles, right? So for instance, you may come to a situation where going to war will actually result in more positive consequences than, like, you can potentially take the example of World War II against, let's say you had to go to war against the Nazis. You could potentially, meaning you probably would argue that would be the right thing to do if there's no other way to stop it. And so, but now there's moral principles clashing once again.
Do we deal with ethical inquiry in IIE somewhere?
No,
Towards
there is a little bit of that. We send them a
moral ethical inquiry
little document.
Yes.
But
That
I think
comes with
we can do that only at the very end,
right.
not at
After
this time.
we have the tools for inquiring into that.
Because moral inquiry is much more complicated than scientific inquiry, and scientific inquiry is much more complicated than mathematics. Mathematics is the easiest.
Yes.
So that's why you start there.
And you start with places where emotions are least in play.
Also, which are the easiest? Like
when you say
Math
easiest,
is not,
I think
it's easy for
easiest,
you.
lots of people are not thinking about the emotional problems.
Yeah.
People are thinking about how do I understand such and such concepts? How do I calculate? From that point of view, math is not easy.
No. Math it is.
Easy in terms of separating the emotional
components from people. Some people get emotional about triangles and circles, but then I think they're outside of the purview of what we can fix.
So there's another point: morality changes from culture to culture, community to community. The question is there something called a basic human moral system?
Yeah, you can definitely see people. There are some principles which cut across
communities and
right?
culture.
And so if you start with those and look for logical inconsistencies in the moral systems and then look for fixes, you'll probably see a lot more similarity between moral systems across cultures than you do. Of course, there'll be things which don't really matter, with like which aesthetic things and so on, which can somehow get tied to morality, which those are unimportant, like how you dress and those sorts of things, which may be unimportant. But there are many things, I think, which if you actually have discussions with people, you would probably come to the same conclusion.
And the whole idea of human rights is based on a universal human morality, the core. And this is like saying no two human beings are identical, and yet there is a unity that connects all the human beings. Humans are distinct from chimpanzees. So the same way you can see the common threads across cultures, across humans, and that's easy to see.
Here's an interesting one, Vaidehi. One last, I won't attempt inquiry at school. Good.
You can
do inquiry,
but not mathematics.
Yeah.
Inquiry in getting children to look for answers for themselves.
Why not?
That aspect is perfectly fine.
Even developing their observational capabilities.
So there are aspects, but not the kind of abstract thing we were talking about.
No, you're not going to get them to write proofs and construct theories and so on. No, not that. But observations, generalizing observations and so on, they can definitely do that.
Right. Imagine, for example, primary school kids, you ask them to watch worms or butterflies or ants and
describe them.
They come up with generalizations so often.
They would love the stuff.
Yes. So what kind of inquiries can I try? It's if you think of it in terms of inquiry, it might tie you down. Instead, what are the kinds of things that a child can, figure out for herself and learn from it? So observing, very careful observation of things, of tiny flowers or little insects, and describing them, telling you about them, and also along with that, perhaps creating stories about them, which develops
Yeah.
imagination and observational generalizations.
Also, the important thing is to not like stop their
Instruct.
to stop their learning.
Yeah.
That's the
Yeah.
most important thing. Like
And if you give them answers, you're saying it'll be okay. I may never be okay with her taking something as a given for answer. That's a good thing. It's important
So,
not
like-
to give answers.
like Mo, you had this friend whose kid when he was told the Earth goes around the
Yeah,
sun.
yeah, yeah.
Yeah.
This child, he was
Yeah.
he,
He was
was
seven?
standing. He was 7. Yeah.
Yeah.
He was standing on the side of the road and jumping. So we asked him why he was jumping,
He was
and
jumping and looking down.
yeah, and he said, my teacher said today that the Earth rotates, and so if I jump up, then if the Earth rotates, then when I come down, I should be coming down in a different place. So I'm jumping to see if it, but the Earth doesn't move because I come down in the same place. Right? This is a 7-year-old.
That's
That's a great argument.
Yeah.
Yes, absolutely.
So the way you can completely spoil that learning opportunity is to now tell him that you're wrong and the earth rotates. Rather, this is something which can happen later. Everyone doesn't need to know the truth or whatever, the established truth and so on at 4 years old or 7 years old or whatever. That's something which they'll understand it eventually. And so don't spoil their learning by telling them stuff which they don't need to know.
There's a group of philosophers who have taken philosophical inquiry into primary school. You can do a not a Google search, YouTube search for philosophy children. And they do this with 5-year-olds and 6-year-olds and 7-year-olds.
A lot of fun.
It's fantastic stuff. But they don't ask questions like, what did Aristotle say about ethics, or what did Plato say, or what did Sankara say about Brahman, and so on. Those are not the questions that they ask.
Philosophy in action.
Yeah. Do watch some of those videos and you will see how inquiry can be taken to primary school.
Philosophy for children.
Yeah.
Is that what you were asking for, Vaidin? Philosophy for children.
Children, yeah. Do a YouTube search. There's a lot of people in Australia, in US, in
the UK.
Yeah.
I will.
Yeah, you want to type it up. Yeah, philosophy. And they use the letter 4. I mean, they
Oh,
double
they-
four, yeah.
oh, they
But
use
doesn't
the-
matter. This
Yeah.
is fine. Yeah.
Last question. We'll give you 2 minutes to.
Anyway, we're supposed to be here only till 6.
6,
But yeah,
2
so I think
minutes.
people started warming up much later.
Yeah.
So the next time we have a meeting of this kind.
Actually, it might be good if we could get feedback from you on whether this was useful, number 1. Number 2, whether this can, in fact, especially for those who can't make it to meetings, monthly meetings, if this is a good idea. We would like to hear from you.
Yeah. And any ways you think we can make it better.
Yes.
So it's on.
Is your 2-minute deadline over?
No, 23 seconds. I just pulled out a number.
This is like restaurant closing at what is it? What is it?
Last order.
Yeah.
Okay, guys, the last few seconds.
Okay, thanks.
Thank you.
Yeah, thank you. Bye.
See you next time.
See you next time. Yeah.